Right, so the next chunk of work that we're going to be looking at, differential equations, is interesting because it overlaps both the pure unit 3 and the mechanics from the applied unit 4. So we'll be flip-flopping between the sort of questions you may find yourself being presented with on a pure exam paper, and similarly questions that we might come across on a mechanics paper or the applied paper. Now, if you cast your mind back to the last work we did in the differentiation chunk that we worked through in the autumn, we did some work using the chain rule to link rates of change. And that sort of question was one where they'd be giving you a formula or a relationship between two variables, here between volume and radius, here between p and x, or whatever, and then we'd use the chain rule to create an equation for a rate of change. So for example, with this one, finding dr dt, so we were going, right, well, to find dr dt, we would be having dr d something multiplied by d something dt, remember? And then we'd be differentiating that and fiddling around with that. So that's work that we were doing where we were taking a function or an expression linking two variables and from it coming up with an expression for rate of change. Well, really what we're going to be doing now with differential equations is the reverse. We're going to be given a rate of change, a dr dt or similar, and from that work backwards to the original expression. And as you would anticipate, I suppose, if going from that to the rate of change was involving differentiation, when we're going to reverse the process, rather than differentiating, we're going to be integrating. So that hopefully has set the scene a little bit. My intro here is basically giving you an idea or a picture of what some differential equations look like. Okay, so a differential equation is one connecting xy and the differential coefficients dy dx, or d2 dy dx squared, and so on. Now they don't have to be linking x and y, they could be linking r and t, v and t, you know, any particular variables that the context provides. So here's a couple of examples. That there, y squared dy dx plus 2xy equals x, is a differential equation because it's got a dy dx in. This one has got d2y dx's and dy dx's in. Both of those are called differential equations. This one is called a first order differential equation because the rate of change part of it is of order 1. Whereas this one, where it's got squareds in, that's known as a second order differential equation. If it had cubics in, it would be third order, and so on. And there's varying methods for solving differential equations depending on your starting point. But in the normal A-level course, which is what we're following, it's only one particular method that we have to follow, and that's called solving by separating variables. So let's take a look at that first example there. So e.g. one.